Hello everyone, and welcome once again to the General Chemistry Laboratory. Today we're going to finish up our discussion of the procedure for gravimetric analysis for sulfate. Hopefully by now you've had an opportunity to read the procedure and watch the videos that covered the initial portions of that experiment. So today we'll finish up and I will explain what you need to have done to complete this entire long project on synthesis and analysis of a coordination compound. I would like to start today by reminding you where we left off and what we're trying to do here. So just a reminder, several weeks ago, while you were still here on BGSU campus, you had an opportunity to prepare a coordination compound called tetramine copper sulfate monohydrate. It was a purple solid you saved in your vial in the drawer. And then we also tested for copper mass percent, and then we left off for break, and now we're looking at finding sulfate mass percents. Because you're not able to be here and you're unable to complete the procedure on your own, I've been showing you what you would have been doing if you were in lab. So this week what you would do is continue working on gravimetric analysis. So what we did in the previous video is we took a portion of the substance, we weighed it, we weighed close to 1.5 grams, and you will be given the exact mass. Shortly the file will be emailed to you with all the information. And then we dissolved it in water. It's ionic, so it broke down in water into ions. And the ion of interest here, the one I circled, is of course sulfate ion that was formed when the substance was dissolved in water. We then added some acid, we heated our solution, and then we started adding barium chloride. Barium chloride was used as a source of barium ions. Barium ions reacted with sulfate in solution from our coordination compound. I might do that. And then barium sulfate was formed. It was a white solid. We added barium chloride in excess, making our sulfate ion a limiting reactant, so that by finding the amount or the mass of barium sulfate reduced, we can then figure out how much sulfate was in our solution and hence in our purple coordination compound. So we also looked at the procedure that covered precipitation of barium sulfate, then its filtration and washing to remove chloride ions. So if you are not familiar with that, please watch the previous videos posted. And then today what we will be looking to do is burn off the filter paper. The filter paper we were using for filtration is called ashless paper, meaning when it burns it doesn't leave any solid residue. The only products of combustion for that paper are carbon dioxide gas and water vapor. And so if we burn off the filter paper, the only substance remaining in the container will be the barium sulfate, which we can then weigh. So now I'm going to go ahead and come up here, and I'm going to show you. This may look familiar. This again is from our previous video. This was the funnel we were using to filter our barium sulfate. And so if I look at the funnel, you might see white solid in the filter paper. I let the paper dry so it would take me less time to burn it. But before I start burning it, I need to prepare my container. The container I'm using for this is called a crucible. The crucible is made of a porcelain. It's a heat-resistant porcelain, meaning it will not crack. It can withstand very high temperatures, so when I heat it, I can be sure that it will not crack. One thing to ensure it will not crack, though, is to look it over on both inside and outside to make sure there are no hairline cracks in it, because if there are, it most certainly will break and shatter during heating. So I have a crucible here in the lid. I pre-weighed the crucible and I have the mass, which again will be given to you. So I'm going to first do what's called ignition of the crucible. Ignition of the crucible is done when an empty crucible is heated with the Bunsen burner, which I have prepared here, in order to burn off any impurities that the crucible might contain. This is done to further improve the accuracy of our experiment, to make sure the impurities will not interfere with our mass of barium sulfate that we're trying to determine. So what I have here is a ring stand with a ring holder. I'm going to take a wire triangle and I'm going to position my empty crucible right here on a triangle, and then I'm going to put the burner right underneath it, and I'm going to heat it for about 10 minutes to allow all the impurities to burn. I'd like to point out that when you first begin heating a container like a crucible, if you have to do it in the future in any of your courses, what you would do is pick up the burner and carefully rotate it around the bottom of the crucible to ensure that the entire outer surface is heated evenly. This also is supposed to help ensure that the crucible will not crack when heated, even though it is heated to very high temperatures. Temperatures may reach up to 800 degrees Celsius here. So this porcelain is extremely heat resistant. We may later see the bottom of the crucible turning red. That's how hot it will become. Of course, it's also important to mention that the entire setup, including the ring stand, the ring holder, will get extremely hot, so we don't want to touch any part of the crucible with our bare hands. We will be using crucible tongs to move the crucible around and possibly reposition it, but for now I'm just keeping it in my triangle and I'm heating it to burn off any impurities. And then we will show you how we're burning the paper in our next video.